So welcome everyone. Thank you for coming today, and especially at lunchtime, because I know it's not usually ideal, but thank you for coming anyways. So I'm going to talk about several topics today, but essentially bytecode generation and a specific library which is called Byte Buddy. So let me introduce myself. My name is Nicolas Comet. I'm a French developer since 7 years, essentially Java technologies. I'm a software R&D engineer at Lectra. Lectra is a worldwide company that is the worldwide leader in the integrated softwares, machines, and cloud services for soft material industries, which means we make machines in France, we ship it all over the world, and we cut leather, fabric, and any kind of soft materials for fashion, apparel, automotive, airbags, any kind of fabrics. I'm also a speaker, obviously, and I'm a member of the Bordeaux JUG. Bordeaux is the city southwest of France, where I'm from. Okay, so bit of advertisement, sorry about that. But my company is actually hiring, so if you feel like coming to France, we are located just next to the sea. It's really nice weather, and we work. We have a lot of positions related to cloud and cloud services at the moment. We expand a lot. If you want to talk about it later after the talk, you can come and see me, and I'll be happy to provide you with information. By the way, if you want to see how it looks, that's where I go before work sometimes to do some bodyboards or surfing with my colleagues. So and then I go to work. So weird. Okay, so how it all began. I learned about Byte Buddy at a conference in Devox France 2015. It was given by Raphael Winterhalter, who is a Java champion and also the writer of the library Byte Buddy. And it was the beginning of the library at this time. So if you want to check the original link, it's here. So I'll talk today about cross-cutting concerns essentially. And cross-cutting concerns are usually concerns that are not business related. They are orthogonal to your preoccupation, let's say to your domain or your regular preoccupations of every day as a developer. When you get some specifications or a user story, you don't get usually cross-cutting concerns, you get stories and domain. So do you know how to spot cross-cutting concerns? It's when you go to your product owner, you say, okay man, I have a caching problem, you know, or even worse. I want to apply some metrics on this method, and he will do this face actually. The product owner will like, wait, what? Okay. Anyways, so examples of cross-cutting concerns: you have logging, caching, monitoring, data validation, real-time constraints, persistence, transaction, etc. But you see what I mean. Usually, it's hard to implement. Why? Because you need to add behavior to your code. But it's not adding behavior just like that. It's adding behavior in a transparent way, which means you don't want your code to be aware of these concerns. You don't want to be intrusive. You don't want it to be intrusive. You don't want to see log or I don't know start timer, stop timer everywhere in your code. It pollutes the code. You're working in Java, so Java is a strongly typed environment, and those constraints or cross-cutting constraints doesn't care about type. They care about these constraints that are orthogonal. So you want to apply those constraints regardless of type, and also in a lightweight manner. You don't want to have an overhead or something. So that's the main idea. So you have some solutions for that. You could implement it with reflection or AOP, aspect-oriented programming, or also bytecode generation. There's more, but I will focus on these three today. So what is reflection? Well, usually reflection is achieved with the package java.lang.reflect. And what is this package? All the classes and types inside are used to represent the meta model of your code. So you use it to read types and discover your methods, your constructors, your fields at runtime. And you can call them, of course, and sometimes in unsafe way and not very nice way, but still it's sometimes permitted. And usually it's mostly in Java it's mostly about introspection, because reflection is a subset of that. But in Java long.reflect is mostly about introspection, and it has a cost. But be careful when I say it has a cost. It has a lesser of a cost right now than before, because a lot of improvements have been made on the JVM, but still JIT is useless. Just-in-time compiler is useless because it cannot predict which method or I don't know, attributes or fields you will look up at runtime. So it has some hard time to enhance the code and to improve it. I'll talk a bit more about JIT just after that. So I'll switch about AOP. Do you know about AOP? AOP was invented because on the top part, usually you had that in your code. You had several cross-cutting concerns: logging, monitoring, caching, and it was spread across your classes, across your services. I don't know anything. So in this not nice way, let's say. So what AOP came to solve and try to solve was let's say a sort of IOC inversion of control. Thank you. Sorry. Thank you. IOC to centralize all these cross-cutting concerns in different files that are not your class files or your Java files, and inject them in your code, in the bytecode without you knowing it. So in AOP is defined by those four terms. An aspect. What is an aspect? It's a description of a cross-cutting concern. A join point is a point in time in your execution of code, which can be described, of course. It can either be it can be anything: a method execution, an attribute access, virtually anything. And advices that are actions taken at this precise moment in time. So you tell what to do when I meet this point, and a point cut that is more or less an aggregation of several join points to gain flexibility when you write aspects. So in aspect J, I don't know if you're familiar with aspect J, but you have your Java classes, yes, your aspect J files, which are a syntax quite close to Java. You provide them to the AJC, which is the aspect J compiler. It's often referred as a weaver because it weaves your concerns into your code without you knowing it. And it produces classes that can be interpreted by the same JVM that you use every day. And the only constraint is a different compiler. But we'll see that later also. So what is bytecode? Well, bytecode is a set of instructions, usually it's a set of instructions. I prettified them here, but yeah, that will be interpreted by the interpreter of the JVM to transform them into machine instructions. Nothing new about that. It's very long. It's been there since the beginning. You know about that. So what is bytecode generation? What is runtime bytecode generation? That gets tricky. So when you compile your code, you get bytecode. Cafe Babe, you all know these terms. So you get the bytecode, and your bytecode is interpreted by the interpreter, which is inside the JVM on the bottom part. On the fly, your interpreter runs code. If you use a library that generates bytecode at runtime, for instance, Byte Buddy, but it can be any other library, it will produce new bytecode at runtime that will be on the fly, interpreted by the just-in-time compiler and optimized for you, which means you don't have to optimize it and you don't want to try to optimize it, because if you do so, you will fail. The just-in-time compiler is really efficient at optimizing on-the-fly code. So that's the principles of a bytecode generation. You're using bytecode generation. Even if you don't know it, you're using it, because plenty of frameworks or libraries are using it already. Spring, Hibernate, Mockito, etc., etc. And I said Mockito is using, since the latest version, Byte Buddy internally to override behavior of your classes or to stub it, mock it, etc. So, do you know this? It's Fibonacci. Yeah. So it's exactly more specifically, it's the naive recursive implementation of Fibonacci. So if why do I take this case? Because if you take the call tree of Fibonacci, or the call stack of Fibonacci, you can see you have several repetitions of call of the function. I've put them in the same color here. So why is it interesting as a case? As an example, I will show you. I will take these examples for my coding later. Why? Because if you take a subset of caching, which is called memoization, you can tell every time I've computed the top node, for instance, Fibonacci of 5, I don't have to recompute it later, so you gain all the call stack underneath. You see what I mean? So that's called memoization, and memoization is basically caching, but on deterministic functions. What is deterministic functions? It's functions that will return the same as long as you provide the same parameters. I'm not talking about mutation, there is nothing about that, it's deterministic functions. So, I will show you some code. I prepared some code in advance because 45 minutes is kind of... tell me if you don't see, by the way. I'll try to make it bigger. So, that's the recursive Fibonacci implementation. You've met that either while studying or something. So, I have 3 projects here: Fibonacci expect-j, Fibonacci Byte Buddy, Fibonacci Spring AOP. So I will try to explain first what I did with Fibonacci expect-j. If I go to, so that's my Fibonacci class. It will be the same for all the examples, so remind it. I'm going to test. Oh, I unplugged my microphone. Anyway, sorry about that. I unplugged my microphone. I'm sorry. Did you die? I'm sorry for your ears. It's a test ng test, and I will invoke 50 times the Fibonacci on Fibonacci of 42 on that. So just to show you, if I run this code, I will get the not optimized version, which usually takes about 1 second, a bit more than 1 second each time I invoke the Fibonacci, and I get the result, which is here. So I'm inside an expect-j project. I don't benefit from expect-j right now. So I need to stop if I find the stop. I don't find it. Okay, I'll let it run. It doesn't matter. So I will just delete the target directory, and we'll show you something. So I'm going to go into the pump.xml to show you that what I have in dependencies is the expect-j runtime, the expect-j weaver, and testng as a test dependency. So that's the only things, I say only thing because it's either an agent or a different compiler for expect-j. You need those, either one of these to implement your aspects. And if I go to the aspects implementation, it is, okay, I have my Fibonacci and I have my memoization aspect. I told you it looks like Java code, but it's not, because you see there are keywords that are different. It's an aspect. I have an hash map. Don't look at it. It's not a concurrent hash map or anything. It's just about the example here. So I have a point cut here, which is the point in time of the execution, and I describe it this way. Every time there is a call to Fibonacci of compute with a parameter of type int, and that returns a long, and I will intercept the arguments and upon the type, the original type, which is a Fibonacci type. And I have an advice here which says around the method. You have different advices, but you have before, after, and around, for instance. I use the around advice, which says every time you have a call to compute, if it's in the cache, you get it. If not, then you proceed the original method call as it was intended. So now I will do a bit of magic to show you if I use an expect-j compiler instead of my regular Java compiler. And if I go back to my tests and I launch it again. Okay. Oh, wow. All 50 invocations done. And it took, on average, I don't know where it is. Oh, okay. Yeah. Here, average time in milliseconds. So you see what we gained. Before it was 1 second in average. Now it's 0. It's in milliseconds, so it's nothing. So yeah, we gained. So that's the first example. That's how I achieved caching with expect-j. Now, if I take Byte Buddy, for instance. I'm going to show the same example. I didn't forget about the benchmarks. It's for the okay. So I have the Fibonacci and the number of invocations that was called on the compute method. So if I go on this time I implemented the memoization with Byte Buddy exclusively. So the only dependency I have in my POM is Byte Buddy, which is here in version 1.75. And if I take my memoization, it's not an aspect, it's a class. And I will use Byte Buddy. So here is my code. The most important part is this method. I say I want a memoization of this type. And I say with Byte Buddy, which is implemented with a nice DSL, I make a subclass of this type at runtime. Everything is at runtime here. Every time there is a call to method named compute, you intercept to this class. I could defer it to some other class, but I will intercept to this class. I load it in the current class, in the types class loader, and that's the reflection method new instance, the same one. So I load it in the class loader. Don't worry about the exceptions. You don't care about the exceptions in Java. No, I'm just kidding. So, and when I say you redirect to this, I intercept it here. So Byte Buddy will use the signature of the method, but not the whole signature of the method, to try to match and to intercept the call. So it's the call to the super method, which is the super object, because if you remember, I inherited at runtime the type that was given. And I say the same thing, but this time I used the Java 8 nice computive absence because it's more elegant. So I return the super method call. If not, then I get it from the cache. And if I run the test, you can see that well, I have the same thing. So it took 1 millisecond. There's an overhead with the IntelliJ and everything. Don't look at these digits. They don't mean. I have more accurate benchmarks. So and about the invocation counter, if I just take, that's my memoization of my Fibonacci class implemented with Byte Buddy, and if I take the original class without using Byte Buddy, well, it will be slow, but that's not what I want to show. The invocation counter. So I print the Fibonacci, which will show me how many times I've called the compute in the Fibonacci call stack, and it's a lot. It's 866 million times. I call compute 866 million times, and if I use the caching, well, nothing is new here with Fibonacci. Okay, and invocation counter. I will call it 57 times. Only 57 times. But that's caching, right? It's normal. So that's why you get why I gained that time on the call stack. Okay, so now let's try some Spring AOP, because Spring Boot has a version of Spring AOP, and it interrupts with either aspect-J or their own implementation of aspects. So I'm using their implementation of aspects. I will explain it later. So if I take my resource, it's the same thing. Oh, sorry, it's not the resource, the service. So the service is the same thing. It's a service, Spring service, and it computes Fibonacci. And I have a resource which is an endpoint that we call Fibonacci of n, and it will give you the result. So now, if I get out of the full screen mode to launch my Spring application, sorry. And now, no, not the beach. So I come back to, I don't know if you see in the browser, but I have the URI here. And if I call with Fibonacci of 42, this is what happens. So it took 2 seconds. It's a bit long, don't you think? And I didn't show you the implementation of AOP, but I will show you it later. So if I reload the page, well, now it's instant. So I only, do you know what happens actually? If I show you the implementation of memoization with Spring, it's the same, but I use the aspect-J annotations, but it's the same thing. I say for this point cut, then you use this advice, that cache, and etc. etc. What happens here Do you know why it happens? Why when I call it once, it will be slow, and the second time almost instant? It's because the way of Spring AOP implements that is not with real aspects, it's with proxies. So only the first call will be cached, it will be fully computed, and then when I get the result from Fibonacci of 42, it will be cached. So when I call Fibonacci of 42 again, I get the result immediately, but it's not real AOP. So, okay, so that's performance comparison. Do not take it for granted. I used you can find the code I used to do these measurements. So it's raw Fibonacci, aspect J, Byte Buddy. Be careful, aspect J is compile time and Byte Buddy is runtime, which means you get the time that the JIT loads and re-optimize your code. And Spring AOP, I told you. So under the hood, aspect J is compile time, or you can also choose post-compile time weaving, on classes and jars. You can also pick load time weaving with an agent, and you can basically with aspect J intercept virtually anything. That's the power of aspect J. For Spring AOP, it's proxy based, and that's the strategy that Spring will take. If there is an interface, they will create a Java dynamic proxy, same provided by the JDK, and else they will use cglib, which is a bytecode generation also library, to generate a proxy and to wrap the call of the original function, and then call the bridge over the proxy over your function. So, and with Spring AOP, you get also good aspect J integration. So the same case as I showed with plain aspect J. If you need more, you just take the dependencies and it will use, with the same annotations, the aspect J implementation and not the proxy-based implementation. So, I'm sorry about that. There's a lot of bullets. People from Oracle world will like it. Nobody about Oracle world here? Okay. So aspect J, I compared the pros and cons of each. So it's more of a feeling I have. Of course, you may not agree with it. That's possible. So aspect J, you get a setup overhead, let's say, because you need an aspect J compiler or an agent. There's a DSL to learn. It's a different DSL, but it's really performant. It's non-intrusive, and you can capture all the things. And with Spring AOP, as I say, it's not really AOP. You can only add behavior on the top of components public method only. So components, I mean Spring components. And that's a plus and a minus. It's a framework. So maybe if you wouldn't like to use a framework, or maybe you would, I don't know. And you get all the Spring ecosystem, everything. And also you can easily migrate to aspect J. With Byte Buddy, you don't have compile time, but maybe you don't need it. It's a library, and it only depends, I will explain later, but it's lightweight. You have a nice Java DSL API, which means with completion you get everything you want. You don't have, you just have to read from the API or press Control Space or no to complete. And it's performance, and you also have an agent writing help. You can write agents really easily. I will show it later. So about Byte Buddy, as I said, I don't know how time I've left. 23. Okay. So Byte Buddy is an open source library under the Apache license, Apache. And it's used by Mockito, Hibernate, Google Bazel, and others. You can find the GitHub repository here, and the documentation here at the bytebuddy.net website. So as I said, it is light. And why is it light? Because the only dependency that the library uses is ASM. So it only depends from ASM, and it wraps it around a nice API. So if you don't want to learn ASM, you have Byte Buddy, and you can become a library writer, because it's not everyone wants to become a library writer, but sometimes you want to know how it works or how you could write one, because sometimes you don't want to inherit from a whole framework or big library just to do one specific thing in your microservice, let's say. So you now can write your own small piece of code to implement your own cross-cutting concern or modifying behavior. So that's, by the way, the ASM version. On the right, it's the ASM version of the code on the left. So I don't know if you see, but it's the visitor pattern of ASM, which means you visit every instructions and you have to know the different JVM instructions like invoke special, invoke dynamics, everything, store, get static, etc. And you all the low level bytecode terms. So it can be a bit annoying. You can learn it, but I will show you why Byte Buddy is way more expressive and way more easy to get in touch with. Not English. So I'm going to now to show you a demo about what you can achieve with Byte Buddy. So let me think. I think I forgot something here in Fibonacci to show you, but I'm not sure. Yeah. I told you could write. You have an assistant provided by Byte Buddy to help you writing agents, Java agents. So I don't know how many of you wrote agents. Yeah, you had. Okay, cool. So that's my memorization aspect, the one I used before. So wait. No, it's this. No, not this one. This one. So that's the Byte Buddy implementation of the cross-cutting concern, well, of caching, of compute method. So you see you have nice DSL to say that you wanted to intercept the method, compute, etc. So I will reuse the same implementation of my interceptor of method, and it's that easy to write an agent with Byte Buddy. I will maybe close the left panel if I can. Yeah. So you are familiar with the pre-main method of the JDK to the hook for the agent. Instrumentation is also JDK, etc., etc. And the agent builder is the Byte Buddy DSL to write the agents. And here I say that for any types I get at runtime, which is this keyword, I will use this builder to intercept all the calls to any methods. Well, I'm a bit, but I can be way much more specific. But here I'd say every call to compute will be intercepted to the memorization class, which is the same as before. And you install it in the current instrumentation here. So that's kind of elegant and with this nice lambda because it's a functional interface here. Okay. So that's the agent demo. Now I will focus a bit more on Byte Buddy itself. And I will show you some dumb domain model, so some dumb domain. So don't take it for. So here I have a cat. A cat is mostly a name and a stomach, as we all know. That's all. You don't need more for a cat. So the stomach is an hash set. So I have getters, setters, etc. If you do domain-driven design, don't write getters and setters. Don't do POJOs, please. .name, etc. Express. Okay, that was a note, a side note. Okay, so that's the cat. Nothing extraordinary. So if I go to my test, unit test here, that's I will show you several ways of doing interceptions and things with Byte Buddy. So you recognize the Byte Buddy root class, which is used for the start of the DSL. So you say, okay, I will make a subclass at runtime of the cat, and if I load it in the current class loader, I make a new instance of it, and here I have a totally type safe cat, the same as I expected at the beginning. So that's why the library is powerful, because you outside the library you are always type safe. So you get the same object. But this object might do things that you don't know, but the end user, will never know what it does. So I set the name Garfield, I feed it lasagna and more lasagna, because we know Garfield likes lasagnas. And I assert that the stomach contains only lasagna and more lasagna, and that its name is Garfield. So if I launch this unit test, ta-da, so it works. So now I will uncomment this piece of code. And no, it's not. Sorry. So now if I, okay, yeah, okay, and if I relaunch this test, the test fails. Why? Because if I look, I expected lasagna and more lasagna, but I got a baby alien inside. So any fans of science fiction movies here? Because everything happened in this ship, and this ship is this class. I intercepted the strange feeling interceptor, and what is inside, in fact, is just plain old Java object with one static method, which says every time you find a method that returns a set of string, you had the previous call that is callable. So I say you call it, you do what the method was supposed to do, then you do some more things, and then you return what. So that's how I did the interception, and I added at runtime with bytecode the different behavior. Okay, so interceptors now. I said the DSL was pretty elegant, and that's the case because you can use the method to you can use the isGetter or isSetter, which are provided by Byte Buddy. It's a static import, by the way. These two, it's matchers. I think it's called matchers, and you say every time I see a getter or I see a setter, I will intercept to this one. And you can also choose to return a static or always the same value, a hard-coded value. But here I have dynamic behavior. So getter, setter, interceptor is, and this is where it's powerful because I told you if you want a nice cross-cutting concern library, it has to be unaware of the types. So that's what the Byte Buddy annotation runtime type is for. Because it says, I don't know what the get method will return at runtime, but it will return something. But I want to intercept it in any case. So by the way, this name doesn't matter at all. The get here, the signature, the only thing useful for Byte Buddy are the supercall and the return, but not the name of the method itself. So I intercept the call to get, I call, and I intercept the call to set, and I call. So here I say I have I match methods having exactly one argument, but you can have several, as many as you want. So you see, it's quite kind of powerful because you can express matchers with nice and elegant tools that Byte Buddy provides you. So if I go back to the test and I launch getter and setter interceptor, what time is it? Okay, 31. If I launch it, you see that I called. I had a call to set method and get method, so I can do logging, for instance, or anything I want with that way. And the end user is still using the same cat as before, so he doesn't know about what happens internally. So now you probably know Mockito. You may not know Cosmopolitan. Do you know it? No, because it doesn't exist. I just wrote a fake version of Mockito with Byte Buddy. It does almost nothing. It stubs. It turns all the objects into dumb objects. So it does nothing at all. And that's what my test says here. So if I mock this cat and I set the name, when I get the name, it has to be null because the object will return null. So if I go to this mock, I go to my custom Mockito, and which is a static instance. Okay, and here is the code. I will close it, maybe the side panel. Okay, so I say that's my contract. You can use interfaces. What I did to expose the static instance of the mocking framework or library I wrote. So you have the type to mock. You make a subclass at runtime of the type to mock, and now it gets a bit tricky, but. You see, I'm only using static methods from Byte Buddy here. Any method that is not native, nor equals, nor returns void, I will intercept them to the null value. It will return null every time. Every time I call any method of this object. So I make a dump object, and then I load it, and then you know the rest. So that's how I implemented dump Mockito. With one line on several lines, but one line still with Byte Buddy. And try catches, but you cannot avoid them. It's because of the reflection API in Java. So now maybe you're. I want to show you that because you can also, let's say, did you use Feign or some libraries that generate implementation of interfaces at runtime? So I wanted to show you that you can do so. If I go to my domain here again, I have an actor, which is just a plain interface. So it has a default method which is greet, and it will say, "Hi, I'm first name, last name," and I'll play my character name. So that's the only contract of my interface. But there are no implementations of this interface. Now I want my frameworks, my library I'm writing, to implement it at runtime, and my user will not be aware of it. So he will code and use the actor interface without knowing that in fact it was my framework that implemented. So how do I do that? So here, what time is it? Okay, 30. So I take the actor interface, I do a subclass, and Mojito and Byte Buddy, if I say subclass of an interface, will immediately implement or do an implementation of the interface at runtime. So now, of course, I have to provide a type because it cannot guess. Well, actually, it will guess one for you, but it will be some random name. It will be like I don't know, UID something. So you don't want that. I say, okay, I will do a female actress, and because you all like Games of Thrones, I think I picked the perfect character for that. Just Emilia Clarke. So I say. That's how I implement the methods of the interface. I say you take the method name, character name, and you intercept to a fixed value, which is the nearest Targaryen. And then I do the same with first name, last name, etc. And I even add a field that wasn't part of the interface. I say you add another field, which is favorite actor, which is public, and who has a type of actor. I make it, I load it into the current class loader, I make a new instance. And if I run this unit test without having any implementation except the one that Byte Buddy provided, I have, oh yeah, I'm just printing, it's done, but I'm just printing the simple name of the, so it's domain female actress here. It's simple name female actress, but I could also call the method here, which I don't know how I called it. No, how did I call it? Greet, thank you. If I greet with my character, it will say, "I am Emilia Clarke. I'll play Clark. Sorry, and I'll play Daenerys Targaryen." So yeah.
Can you call the new field? Can you try a new data for new field?
Yes, you can. No, but it won't be accessible because you cannot be reachable. So you can create getters and setters, but only for internal operations. Because your contract is still the actor interface. So what your end user will see is the actor interface. So you cannot use a method that is not known by the type system. It will exist at runtime. So if I put a breakpoint in this object, you will see the getter, and you will see you could also with introspection or reflection see the method, but you cannot as an end user use it. So yeah. So now I want to, if I have time. Yeah, 37. I want to show you, sorry, an implementation of a light security framework, let's say. So I have my security framework is here. Yeah. So I have an interface which is a safe, and the only contract of my library is to return a safe instance of the instance I give in parameter. So if I go to the implementations, I'm using, oh sorry, I'm not in the implementation. What happened? Okay, implementations here. I also forgot I have a lock annotation, which has a key. So don't implement that in production. It's there are plenty of other libraries that does that. It's just for the example, okay? So I have a lock interface, which is a lock annotation, sorry, I wrote, which has only a field key. And I will say every time you want to open a safe instance of something, you have to look for the key. And if the key matches, then you can open. And if not, you cannot open the method at runtime. And the check is indeed at runtime. So, Buddy safe implementation. So here is my object. I have my key attempt, which is, okay, I come with my key, and I will check it against the expected key. And here's how I implement my safe instance. If I do a subclass, you know the game now. If the method is annotated with the annotation lock, which is part of my library, I intercept to this, I load it in the current class loader, and I return a new instance. And here is the interception on any method that returns any type at runtime. I have the super method, and you can see here I have the origin method, which is the method I intended to invoke when I on my super class also. So what I do here, it's the part where the check is done, is like if the key inside the annotation lock, which is the keeper of the key, the one that knows which key is relevant or not, equals the key attempt. It doesn't equal. I throw an illegal state at runtime saying you cannot call this method because you don't have the correct key. So if I go to the safe test here, you see I have UID here, and if I go to my implementation of Buddy safe, no, sorry, okay, I will give it the proper key right now. So I can call the method, and it returns the total amount of the bank. But if I, for any reason, change the number here, then my library at runtime will say you are not allowed to call this method. You have an illegal state, and it will say the method bank account total cannot, because I logged that, cannot be called. Key is not correct. And then that's how you can easily implement nice cross-cutting concerns or add behavior at runtime on your code. Which is pretty neat, and I found it pretty interesting to know how it works. So just to conclude, and then we can not the beach again. What? So just to conclude, so from what I've seen, you can have also different opinions. It's normal, but when you want to add behavior, in your code, you can implement it either with AOP, as I showed you, but there are it's a bit more cumbersome. You need to provide more efforts to do so. And also, if you have production code, not everyone wants to compile your source code with another compiler than a regular one, let's say. It can introduce some complexity a bit, but well, you could also pick an agent for AOP, which is a bit more lightweight in this case. And you can also, if you want, if you want to write libraries or frameworks or agents, because it's pretty nice as I showed, you could use Byte Buddy to implement your own library or even to refactor an existing library. That's what happened with Hibernate and Mockito. And Rafael Winterhalter submitted the merge requests on those two projects, and it got merged. So he refactored the engine inside with Byte Buddy instead of ISM, I think, or was it B-cell? For Mockito? I don't remember. Sorry, CGlib, yeah, you're right. Maybe for Hibernate, for lazy loading, it was ASM, I think, but I'm not sure. Well, anyways. It was B-cells too? And it uses also Obgenesis, which is a pretty nice Obgenesis. Yeah. Henri Tremblay is here. Okay, and for discovering at runtime, you could use also reflection. For instance, if you want to implement custom serialization, I don't know, because you have a very specific need, but I wouldn't recommend it because you have nice custom libraries that are like Jackson or anything, or Jor that do these kind of things for you already. You don't have to re-implement the wheel. And you can also do nasty things with reflections because you cannot be type safe anymore, such as setting private fields. And we actually used Jor I don't know the pronunciation, but the reflection library to set private fields, but only when we were knowing what we were doing for a project where we had domain model and for DDD project, and we didn't want any intrusion in the domain code because the domain has no dependencies, and we wanted still to do some serialization on it. So we had to set to access private fields in an unsafe way, but still okay. So it's almost time. I don't know if you have any questions. 1 minute, and afterwards we can talk outside if you want to ask questions or talk about anything. Thank you very much for your time.